Okay, today we're going to be looking at a new way of writing equations for lines. Okay, now it's still a line, and in fact we can bounce back and forth between this way and the y equals mx plus b way. Today's way is called point slope. Okay, and the reason it's called point slope is you can look at it and pretty quickly tell a point on the line and what the slope of the line is. Whereas with y equals mx plus b, which is called slope-intercept form, you can quickly figure out the slope and the y-intercept. We're going to be writing out this equation given a point on the line and the slope of the line. Some of my students were asking, well, are we solving today for y or x? No, we're writing an equation. In a way that is solving, but we're writing an equation in a different form, point slope form. How can we compare this? It's kind of like two different words in English that mean the same thing. For example, if you said I had some sweets after dinner or I had a dessert after dinner, that's the same thing, right? Two different words that mean the same thing. And so point slope equation can represent the same line that a y equals mx plus b equation can, a point slope intercept equation. So let's get down to it and explain where this formula comes from, so I'm not just giving you a formula without explaining it. So the question is, where does the point slope equation come from? Well, first of all, it starts with the equation for slope, which is rise over run, namely y2 minus y1, the change in your y values, your vertical change, divided by the change in your x values, x2 minus x1, or your horizontal change, hence rise over run. The first thing we're going to do, one of my students quickly pointed this out, is use the symmetric property of equality to flip these. In other words, if a equals b, then b equals a, and whatever, you can flip the equation, it's still equal to each other. So we're going to move this over to the left and move the slope to the right. Next thing we're going to do is multiply both sides by this denominator. Okay, so multiply both sides of the equation by x2 minus x1. That will get rid of the x2 minus x1 in the bottom of this fraction, and it will move it to the right. Okay, so there's the cancellation of the x2's minus x1's. And finally, not finally, but almost finally, now that these have canceled, we are left with y2 minus y1 equals m times x2 minus x1. Again, this ended up over here because you have to multiply both sides by x2 minus x1. The final step, so with point slope form, you could theoretically leave it this way, but it's normally written just the y2 changes to y, the x2 changes to x. And that's kind of like, that's because like with y equals mx plus b, we have the same thing. Like if we had y equals 2x plus 4, the y and x would still be left in the equation. You could write it as y2 and x2 or whatever, but we usually just write y and x. So it's just changing it to a different form. It means the same thing. This is the final point slope form. Y minus y1 equals m times x minus x1. This is point slope form, and when we solve these equations today, not solve the equations, but when we figure out the equations, they are going to be in this form. Okay? Y minus y1 equals m x minus x1, and just to reiterate, that comes from the equation for slope, rise over run. So let's get down to it, look at some examples. Alright, first example, we have the point slope equation for the line that passes through the point 1, negative 3 and has a slope of 1/2. Label the point and the slope. First step. Now we're going to label the point x1, y1. You'll see why in a minute, but that's our first and xy value that we're given, so that's why they're called x1, y1. They're the first ones. So x1 is 1, y1 is negative 3. We still label the slope m as we did before with y equals mx plus b. Second step, you're going to write out the equation for the line, just like you would for y equals mx plus b, but we're writing out the point slope equation. Why? Because in the question it says write the point slope equation. Had it said write the slope intercept equation, we've already learned how to do that. But this is point slope equation. So that's the equation we're going to use, which we just showed how we got there. Y minus y1 equals m times x minus x1. Next, we're going to plug in the values that we labeled. We labeled negative 3y1 up here. So we're plugging in negative 3 for y1. We labeled x1, 1. We labeled m 1/2. So all that stuff gets plugged in. Plug in 1/2 for m. Plug in 1 for x1. And so notice when you're plugging in a negative number, make sure to put it in parentheses. If it's positive, you don't really have to do that, but it's also good practice, so you can do it as well if you want. And then you simplify for step 4. And so if you're subtracting a negative, you need to turn it to positive. Other than that, you're good. One of my students was asking, do you distribute the number outside the parentheses? No. Okay. Point slope form usually includes a set of parentheses. You do not distribute it. Why is that? Well, the reason it's point slope form is you can easily figure out a point and the slope of the line. To get the x value, you just flip this sign. So the x value is 1. Since it's being subtracted, it's positive 1. The y value would be the opposite of this, which is negative 3. So a point on the line would be 1, negative 3. The slope is just the number in front of the parentheses. That's why it's called point slope form. You can quickly look at it and see what a point on the line would be. So again, it'd be the opposite of that 1 and the opposite of that negative 3. So your point would be 1, negative 3. Your slope would be 1/2. In fact, I'll write that out just to show you what that would look like. So the point's 1, negative 3, and the slope is 1/2. And that's what we were given, so it's easily to take the equation and go backwards. All right, so next equation, the next example. Okay, write the point slope equation, so same thing for the line that passes through the point negative 5, 9, and has a slope of 4. So label the point x1, y1, label the slope m. Write the equation for write the point slope equation for step 2. Plug in the stuff for step 3, so y1 is 9, x1 is negative 5, slope is 4. We've plugged them in, and then final step is to simplify. Y minus 9 becomes y minus 9, but x minus negative 5 becomes x plus 5, and here is our equation. And again, you can quickly look and see, first of all, the slope is 4, that's obvious, and then the point would just be, all right, so the x value is the opposite of that, so that's negative 5. The y value is the opposite of that, which would be positive 9. So we have a point negative 5, 9, and the slope 4, which is obviously what we were given to begin with. But again, it's called point slope form because you can easily read it to figure out a point on the line and its slope. What happens when you have a slope of 0? So write the point slope equation for the line that passes through the point 1, 2 and has a slope of 0. Okay, so label the point, label the slope, use the same formula that we used before, point slope formula, hopefully you're learning it by now. Plug in y1, okay, so same steps. Why can't I get both of those on the same page? Let's try this. Okay, plug in x1, which is 1, plug in 0 for m. Now here's the thing, 0 times anything is what? 0. So what's going to happen is that whole thing on the right turns 0, and it's just y minus 2 equals 0. This is technically still in point slope form. What it tells you basically, though, is only the y value. You're not able to see what the x value is, but you can see that the y value is 2, and in fact it doesn't matter because the y value will always be 2. Okay, it doesn't matter what the x value is because it's a horizontal line at y equals 2. So it's still point slope form. You can easily tell that. If you were to move the 2 over to the right, it'd be y equals 2, and that'd be slope-intercept form. You could tell that it's a horizontal line. So it's the same thing. All right, write the slope equation for the line that passes through the point negative 10, negative 11 has a vertical slope. So this is like totally different than what we did but just now with, slope is 0. Now we have a vertical slope, and one of my students pointed out that's an infinite slope, and that's true. But in order to get this in point slope form, it's a little tricky, so I will explain that to you. You're still going to use the same equation, however, you basically don't have a slope, right? It's all rise and a run. And so the first thing I want to point out is your slope goes away. Okay, it's undefined, right? It's not there, so we're removing it. The second thing is a little bit harder to explain. Your y minus y1 is going to turn to 0. The reason for that is, your x value will always be negative 10, right? So technically, you could you could stay at negative 10, okay, and your x value would still be negative. And if you stay at negative 10, your y value doesn't change at all, right? It would just remain 0. That's a very rough interpretation of why y minus y1 becomes 0, but just know that when the slope is undefined, your y minus y1 becomes 0. Why? Because your x value is always going to be negative 10 no matter what. Okay, so you're going to plug in negative 10 for x1. You get x minus negative 10, which becomes x plus 10. And again, the left is 0, and this is actually point slope form. And let's talk a little bit about how to interpret this if you were to be given this equation. So first of all, if we subtract the 10 from both sides, we get x equals negative 10. And that's pretty obvious, right? It's a vertical line at x equals negative 10. That would be considered more closer to slope-intercept form. And so we can see that x is always negative 10. Here there are no y values, and so basically it's telling us you don't have to include y in the equation because x is always negative 10. So there you have it. There is point slope form of an equation of a line. If you have any other questions about this lesson, let me know.